part we're going to discuss is this stuff called algebra and the real numbers. And this is a really short lesson because I think for most of this you can read your book and figure it out. It's just names of properties, mostly for stuff you already know is true if you just gave a name to that thing. But one thing that I want to make sure you know are the names for certain sets of numbers, because I use them without knowing what I'm doing that, and so you got to know what I'm talking about. Kind of like in my Russian class, I've got to know what costume means. Actually, not really, but... So the natural numbers are the ones that are the most natural for you. They're the ones that you count with. And so the one funky thing about natural numbers is they begin at 1. So this is the numbers like 1, 2, 3, etc. So all the counting numbers. If you want to read about some math history, there's like a whole bunch of history about how there was debate over whether 0 really was a number or not. So, and then the integers, what you add in for those is you add in all the negatives, and by negatives I mean all the counting negatives, all the whole number negatives, and you add in 0. So that's things like ... -3, -2, -1, 0, 1, 2, 3, etc. And the letter for natural numbers is N, the letter for integers is Z, and you're kind of like, what the heck, why did they use a Z for that? The reason is that a lot of math was done in German back in the day, and so the word for integers in German I think is Zahlen, and that's where the Z comes from. So that's why they pick Z. Rational numbers, so in rational you see the word ratio, right? Ratio means fraction, right? Rational numbers are all numbers that can be expressed as fractions. So all numbers that can be expressed as fractions. So positive or negative, does it make sense that the numbers like 3 is also a fraction by default because it's 3 over 1? Okay. Did anybody learn what rational numbers are in terms of decimal expansions? They're decimal expansions that either end or repeat. Yeah, so decimals that end or repeat. And one thing we're going to do in this lesson is talk about how to take a repeating decimal and make it back into a fraction, which is kind of an interesting thing. Irrational numbers are numbers whose decimal expansions do not repeat and do not end. So decimal expansion does not repeat or end. What's everyone's favorite example of an irrational number? Pi. Yep, exactly. Yum. I should bring pi on Pi Day. If we have class, I'll bring pi. Okay, another one. Have you heard of this number called E before, perhaps? 2.71-ish. Another number is root 2, right? That's not rational either. So there are lots of examples of rational numbers. Basically, any square root that you can't work out nicely, like root 7, root 13, those are irrational numbers. And then real numbers are all rational and irrational numbers. And I'm not sure of your background, but the reason that they're called real numbers is that there's this other set of numbers called imaginary numbers. So basically, real means not imaginary in some sense. Okay, imaginary adds in this extra dimension. Actually, it makes it, yeah. So that's the vocabulary that I use. And I'll also post these notes, like my own versions of these notes online. So like if you find it's better for you to just like listen and then write later, that's also okay. All right, so then you have to know how to do stuff with fractions because, you know, it's math class, this happens. So when you add, you have to have a... Yeah, exactly. And this is an easy one, right? What's the common denominator going to be? 15. So you multiply 1/3 by what? 5 over 5, yep. 5 over 5. And you multiply 6/5 by 3 over 3, yep. And the reason that works is that 5 over 5 is just 1, right? Multiplying by 1 doesn't change anything, right? So that makes 5/15 plus 18/15, is that right? Sometimes I can't multiply, so just if something seems wrong, it was me doing a stupid. So is that 23/15? Okay, great. And that does not reduce, so there's your final answer. I know when, like just in general, like in high school, they kind of like harp on, make your numbers mixed numbers. Don't ever do that. Okay, you don't have to. Never make it a mixed number. And the reason is that I think that Alex will count you wrong. And the reason is that a mixed number is a bit ambiguous. Like if I give you 1 and a half, it's not clear, is that 1 plus 1/2 or is it 1 times 1/2? Which one does it actually mean? It really means 1 plus 1/2, right? Which is totally not obvious. Does that make sense? So my suspicion, I know WebAssign is like this. I'm not sure about Alex. I think Alex has a mixed number button. Is that right? Because you know, Rachel, because you used it recently.
No, it just tells you to simplify more. It doesn't have to.
Tells you to do it. So Alex is smarter than WebAssign. Tells you that you're right, but makes you like try to change it into the form it wants. All right, multiplying fractions always get students because they think that they have to get a common denominator. Guess what? You don't have to. Yeah. So you can do this 2 ways. What you can do is multiply just straight across, 1 times 6, 3 times 5. You don't cross multiplying is something totally different. Cross multiplying occurs if you have something like x over 3 equals 10 over 2.
Oh, I forgot what it's called then.
What you're trying to say is you're thinking of cross reducing.
That's right, yeah.
That's what you're thinking of, and I totally understand. Do you guys know what he means? He means take this 3 and cancel that 6 sum. Okay, and the technical way to write that step, if you want to do it, you can kind of reverse the order. You could say 6 over 3 times 1 over 5. Just flip-flop the order of the numerators. Does that make sense? Because when you multiply, order doesn't matter, does it? No, 1 times 6 is 6 times 1, right? So, and then the 6 over 3 reduces to 2 over 1. So 2 over 1 times 1/5, that makes... Let's see, my eraser tool occasion disappears and I don't know how to fix it. You get 2/5. Ignore that. Okay. And for division, have you heard the words that dividing by a fraction is multiplying by the reciprocal? Has anybody ever told you why it is that way?
Well, multiplication and division are essentially the same thing.
Yeah, but it's a little bit more technical than that. So see if this makes sense. So if you have like 7 divided by 2, it becomes 7 over 2, right? Mm-hmm. If you have 1/3 divided by 6/5, it becomes 1/3 over 6/5, right? Mm-hmm. Okay. And then you have this fraction and a fraction, which is totally bad math grammar. Like, you don't want to do that. So I want to make that bottom denominator into a 1. And if I multiply by 5/6, that makes it into a 1, right? And you have to be fair because it's math class and math is fair, unlike life. So if you multiply the denominator by 5/6, it's a joke, you're supposed to laugh at that. The numerator also gets multiplied by 5/6. So the denominator is now like canceled and gone. So we just have 1/3 times 5/6. The denominator has become 1. Do you see that the multiplication by the reciprocal step is sort of like what happened? The second fraction is what flipped, right? That's why that is that way. They just don't tell you that in 3rd grade or whenever you learn fractions. And you get 5 over 18. Okay, so, I mean, not rocket science, but my guess is, had any of you ever seen it explained this way? No? Does it make sense, though? Mm-hmm. Yeah, okay. So, that's why it works that way. And now the next thing I'll talk about is some properties of numbers, i.e. names for stuff that you already know that this is true. So, addition and multiplication are both called commutative, which means changing the order in which you add 2 numbers or multiply 2 numbers doesn't matter. You know that that's true already, right? So that's called commutativity. Addition and multiplication are associative because changing the grouping of these numbers, of 3 numbers that are added or multiplied, doesn't matter. So, for example, something like 1 plus 2 plus 3 is the same thing as 1 plus 2 plus 3, right? That's, and I think about that as the parentheses are who you associate with, and who you associate with changes. Okay, that's how I remember what's what. The number 0 is called the additive identity because adding 0 to a number doesn't change the result. What's the multiplicative identity then?
1.
1, because multiplying by 1 doesn't change the result. So the additive inverse is the opposite number if you're adding numbers together. So what's the opposite of a number r?
1 over r.
Additive.
Negative r.
Negative r. So the point is the numbers have to add up to 0. When they add, they cancel is kind of the premise. So examples like, 3 and negative 3, stuff like that. The multiplicative inverse is, so Cole, you can say your answer again. 1 over r. So, for example, what multiplicative inverse of 3 and 1/3, right? What if I gave you a fraction like 2/5? What's the multiplicative inverse of 2/5? 5 over 2. So, and what you have to do for the homework in ALEX that tests that, it kind of gives you a list and it says, here is something that's done, which property is it? I'm not going to make you memorize those names, really. It just is like you have to have seen them so you kind of like know if people use them. Oh, it's associative. You know what that means. Okay, and then the other thing that's kind of fun is converting repeating decimals back into fractions. 0.6 repeating, that makes 2/3, right? You've seen that enough, but how do you prove it? And actually, I want to change it because I want to do the fun one. Let's do 0.9 repeating, okay? Just because it's going to blow your mind, okay? 0.999. Call it x, okay? So let 0.999 be x. I'm going to take x and multiply it by 10. So I got 10x. What happens when I multiply the 0.99999 by 10? What do you get?
You move the decimal.
Move decimal over 1. You get 9.9999. Okay, blah, blah. And now if you do 10x minus x, that's equal to 9.999, blah, minus 0.9999. And what happens when you do the subtraction on the right-hand side? You just get 9. What do you get on the left-hand side?
10.
Oh, if you have 10 x's and I take away one of your x's, I steal it, you now have 9 x's. And then how do you undo 9 times x? Divide by 9, you get x equals, does that blow your mind a little bit?
A little bit.
A little bit?
Yeah.
Yeah, you're like, oh my gosh, whoa, 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 0.9 repeating is like, can't be 1, that can't be right. Here's another way to think about that, why that has to be true. What is 1/3 plus 2/3? 1. So 0.3 repeating plus 0.6 repeating is 0.9 repeating, right? Therefore also has to equal 1, right? So it's a special thing about decimal expansions is that the words they're not unique. There's more than one that's right. It's like the number 2 is equal to 1.9 repeating forever. Go tell your little siblings, it'll blow their minds. So, all right. So the reason I chose to multiply by 10 was that move the decimal place over 1, which allowed when I did the subtraction, all the decimals went away, right? If I gave you something like 0.7 repeating, so call that x, would multiplying by 10 be good enough? No, multiplying by 10 moves the decimal over 1 spot, right? You want to move it over how many spots? 2. So multiply by 100, exactly. So 100x will equal 17.171717, etc. If your pattern was in groups of 3s, you'd multiply by 1,000, right? Does that make sense? Okay. And then 100x minus x is equal to 17.17 repeating minus 0.17 repeating. So if you have 100 x's and I steal one because I'm an evil, mean person, you have 99. Your math teachers are all mean. They all steal your x's, right? Equals how much? 17. So x is 17/99. And occasionally you can reduce the results that you get. In this case, that's not true, but
Is there any case where you could, like, have a different process to get a fully reduced answer?
I don't know of a way to get a fully reduced answer right off the bat. Maybe there's a way that I could think of using calculus 2. I can't remember if it reduces or not. Nothing using just algebra that I know of. Okay, so that's, because you really have to use the whole tens property, you could move the decimals over, so I'm not sure. But I don't think so. Okay, so that is the end of the first lesson, like page 1. So